Hello, everybody. So we are going to be solving equations, and this is a great part of the chapter. After this, we're going to be solving real-world equations. So these are all just made up to serve as exercises, and then we'll see how we can use what we've learned to solve some real problems. So first of all, some major reminders. The three main properties, if you're adding two logs that have the same base, you can write it as one log, but just the product of these two powers. And this is reversible. So if we had log base 2 of 15, I can separate into these two logs. If you're subtracting two logs, you divide the powers. It's not log divided by log. It is log base 2 of 3 divided by 5. And then a power to a power property, this 5 will swing out in front. And 3 to the x plus 2. So any base, remember the base has to be positive and it can't be 1. This will always, 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 always produce a positive number, always. And logs are the inverse of this. So logs can only receive a positive. So log base 3 of, this is some positive that's in here. So this interval is the range of exponential functions, but it is also the domain of these log functions. Logs are exponents. So when you see this batch up here, you should be thinking an exponent plus an exponent equals this new exponent. And log base 3 of some positive is going to equal something. It's going to equal an exponent. And that exponent would go on 3 that would result in some positive. All right, what can I do here? 4 to the x plus 1 equals negative 17. This should make you cringe because that's absolutely impossible. You can't start with 4 and raise it to something and get negative 17. This has literally no solution, not imaginary, not anything, no solution. This one, however, how would you solve for this? Well, you don't know the logarithm. So I'm sorry, you don't know the exponent, which is a logarithm, but you don't know the exponent. You know the base, you know what you end up as, but you don't know the exponent. So good thing for us, logs are exponents. So this logarithm is x plus 1. X plus 1 is the exponent. And now you go to your calculator, log base 4 is 17 is some number. You subtract 1 and you get x. All right, how would I solve these three? What would be my first step in solving these three? They all have 2, they all have a 99. Some unknown squared equals 99. 2 to some unknown equals 99. And log base 2 of some unknown equals 99. So they all equal 99. Well, this one is a pre-algebra problem. You have the inverse of squaring. How do you undo a square? You square root. But did you do plus or minus? If you take the square root, you have to account for plus or minus. How do you undo this? If you're thinking take the xth root, that's awesome. I wish logs were called the xth root because that's a great word for them. But someone before I was born chose the word log. Maybe they were a lumberjack. I don't know. But this exponent is x. I don't know the exponent, but I do know what equals exponents. Logs do. So log base 2 of 99 equals x. So this is solved. Remember, to solve means to find out what x is. Guess what? X is this. And if you want to round it, you'd have to go to your calculator and put this into your calculator. Your calculator will tell you the exponent that would go on 2 that would result in 99. What do I do here? Remember, logs are exponents. So this logarithm equals 99. That means 99 is the exponent on 2 that results in x. All right, let us solve. So 5 times 2 raised to the x over 2 equals 40. Only the 2 is being raised to the x over 2. If you're thinking, ooh, 5 times 2 is 10. Oh, that's bad news, guys. You just broke the order of operations. You can't multiply before you take care of exponents. So if this was all you had, you'd be stuck. But luckily, there's an equal sign. That means I could do whatever I want as long as I do it to both sides. So I will undo multiplying by 5 the only way I know how. Divide by 5. So I will divide both sides by 5. And I get this. And now 2 to some unknown equals 8. Well, the unknown, oh, we just jumped right to the end. The unknown is the exponent, and that is the log. So I could write this as log base 2 of 8 equals x over 2. Log base 2 of 8 equals x over 2. I can then multiply both sides by 2. And I've solved it. X equals 2 times log base 2 of 8. But log base 2 of 8 is 3, because 3 is the exponent that would go on 2. That would result in 8. And so 2 times 3 is 6. So the answer is 6. What's going on over here? 5 to the negative x over 4 equals 120. By the way, even if there were a negative sign in front, this is something we have to know. This is part of the language. Ugh. Come on. If you're faced with this, like let's say on the SAT, how would you react here? You have to know that bases are never negative with exponential functions. It's not negative 5 raised to this. It's actually negative 1 times 5 raised to this. So the first thing you would do here would be divide by negative 1. But that's not the case here. You just have plain old 5 raised to this. I don't know the exponent, so I will convert it to a log, because logs are exponents. Log base 5 of 120 is this exponent. And now log base 5 of 20 is just a number. Let's be clear about that. Log base 5 of 120 is a number. 5 to some power equals 120. And whatever that exponent is, that's what the log equals. And I'm 2 steps away of solving for x. I had to undo division by 4, and I had to undo multiplying by negative 1. I could do all those in one step just by multiplying by negative 4. And so there it is. This is the answer. X is negative 4 times log base 5 of 120. That is the exact answer without any rounding. So, and on the test, you're going to be asked for exact answers, and this is it. To go to your calculator, you could then type that into your calculator and round it, and you get this number, negative 11.899. Problem 3, a log plus a log equals 4. So an exponent plus an exponent equals 4. Remember, if you add exponents, you must have multiplied. So I hope you can guess what's underneath here. Log base 2 of 3x equals 4. But now what? Now logs are exponents. So 4 is the exponent on 2 that would result in this. So 2 to the 4th equals 3x. And 2 to the 4th is 16. And to undo 3 times x, you would divide by 3. So the answer is 16 thirds. And a lot of students don't like to leave it as a fraction. I don't know why. This is better because you could put it in your calculator and do 16 divided by 3, but then that's just extra steps. Why do extra steps? Just leave it right here. 16 thirds is totally acceptable answer. All right, number 4. Hopefully you're pausing the video and trying to answer these before the solution is known here. So if not, begin that now. So solve for x. Pause the video. We had to undo lots of things. First, the most obvious one, maybe add 5. So I had to undo that. Subtract 5. This x is being multiplied by 0.02. So at some point, I'm going to have to divide by 0.02. The x is in the exponent spot, so I had to undo that. That means I need a log. And then I got this e here. That's going to tell me what kind of log I need. And 4, I'm multiplying by 4. So at some point, I'm going to divide by 4. So I wasn't keeping track, but that's a few things we got to do. And we start with the last thing. We start with this adding 5. So if you were to type in x, like if I said evaluate this when x is 3, you would do 0.02 times 3. Then you would take e raised to whatever that number that is. Then you would do 4 times whatever number you got, and then you would add 5. So that's following the order of operations. So to solve, you go in reverse order. Whatever you would have done last, you undo first. So the first thing you undo is adding 5. So you subtract 5. Now, 4 times e, you have to undo the 4, so you divide by 4. And now you have a base that equals 2. That's good because remember, what the base is always positive, and the answer is going to be a positive number, and that's what I've got right here. If this was e to the 0.02x equals -2, it would have been great. It would have been game over, no solution, because there's no way you could take e raised to a number and equal a -2. So now you convert to logs. This exponent is a log, but what kind of log? A log base e. Don't write down log base e. Don't do it. It's ln. Natural log is log base e. And then to solve for x, you just got to divide by 0.02. So there's your answer. That is the exact answer. Rounded, you get that. All right, number 5. 2 times the natural log of x minus 3 equals 8. And well, this will be our last one. So you divide both sides by 2, and you get this. And now you got this one logarithm. Forget any ideas of adding 3. That's a massive mistake. This x minus 3 is part of the logarithm. And I can't remember if I said this before, but logarithms are exponents. So 4 is the exponent. On what? On the base. This base is base e. So e to the 4th equals x minus 3. And you're one step away. Add 3. So x is e to the 4th plus 3. That's a beautiful answer right there. You could go to your calculator and type e to the 4th and add 3 and give me a decimal. That's fine too, but this is full credit. This is the exact answer.